question number is 21, where we found that the standard gives free energies of formation of C graphite and C diamond at T equal to 298 Kelvin. The values are given, that is delta G naught formation of C graphite. C graphite is given as equal to 0 kilojoule per mole. We know that is a standard condition, mole, and then mole, and delta G naught formation of the carbon diamond. Carbon diamond is given as that is your 2.9 kilojoule per mole. 2.9 kilojoule per mole. So this is given this thing, the data, and the standard free. Then the standard state means the pressure should be 1 bar and substance should be pure at a given temperature is true. The conversion of graphite to diamond reduces volume by 2 into 10 to the minus 6. That means when it is converting to graphite to diamond, C graphite, when it is going to C graphite to C diamond, the volume change. The graphite to diamond, the volume change reduces. That means delta P basically we are getting minus 2 into 10 to the power minus 6 meter cube per mole. It is given when graphite is converted to diamond, the change is happening, and graphite is converted to diamond isothermal to P equal to 298 Kelvin. 298 Kelvin, this is happening. So change temperature delta T equal to basically 0. The change in temperature is 0. When they are saying that a constant temperature is happening, the pressure at which graphite is in equilibrium with diamond is. So that means we have to calculate the pressure at which it is basically it is in equilibrium graphite and is in equilibrium with C diamond basically. So this is a question. Now to solve it, we know there is an equation for the Gibbs free energy, the famous Gibbs free energy, that is equal to G equal to, we know, H minus Ts. I will give you the brief workout first, and then we can apply this expression particularly. For example, G equal to H minus Ts. The G is the free energy, H is the enthalpy, T is the temperature, S is the entropy. So if I take differential in both the sides, you get dG is equal to basically dH minus Tds minus SdT. And what is dH? It is basically dQ plus Pd minus Tds minus SdT. So if you go through this particular expression, then it is basically du plus Pdv minus Tds plus Vdp minus SdT. We can write, and you know this part is basically 0 because everybody knows that du plus Pdv, du plus this is basically du plus Pdv is the dq, dw, and dw minus Tds is again dds is equal to dq, because we know ds is equal to dq reversible by temperature. So therefore over here, since it is reversible process, du plus Pdv equal to basically dq reversible and minus dq reversible plus Vdp minus SdT. So therefore we come out to be, that is dg is equal to, we get Vdp minus SdT. Is very important relation. Anywhere we use this particular expression to solve many questions. Like for example, theoretical aspect, if you see the dg equal to Vdp minus SdT, in that case basically it can be used for phase change, liquid to solid to liquid, or liquid to vapor, vapor to liquid. For that physical equilibrium, we apply this particular expression. We can apply this in solution chapter to find out Raoult's law. Also, I can apply this particular expression to find out temperature coefficient of the cell EMF. So this is a very important equation from which also you can get Gibbs general relation, so on and so forth. So dg is equal to Vdp minus SdT. This is the expression. So this is the final conclusion that dg equal to Vdp minus SdT. Now on our case, basically in our case, we understand that dg equal to Vdp minus SdT. Now as temperature is constant, so we will take a 0, so you can write dg equal to basically Vdp. Now that means what if I say that, see, there is a change basically from diamond to graphite to diamond, the change is happening. So therefore I can write delta G of this D. If I write, then I can write delta V into dP, let's say it is P1 to P2, let's say it is P1 to P2, and it is delta G1 not, delta G1 to delta G2, for example, delta G1 to delta G2. Then I am talking about P1, at P1 it is a delta G1, free energy for this reaction, and V2, free energy for the reaction is delta G2. So if we talk about this particular expression, so then we can get that. So then we can get that. We can write that. We can write that delta G for the allotropic change. You can see it is basically allotropic change delta GA. So therefore we can write delta G2 minus delta G1. That is equal to basically del V. What is the del V? The quantity is given us. That is basically 2.9. That is basically you are given us delta V. We found that this is 2. This is basically 2 into 10 to the minus 6. 2 into 10 to the minus 6 basically minus 2 into 10 to the minus 6 basically delta V, and then dV is basically P2 minus P1 basically P2 minus P1. That is particular thing. So therefore if we put the values over here, we get minus 2 into 10 to the minus 6 into P2 minus P1. You can write that is 1 minus inside is P2 basically. We know it is 1 per patient initially. So now delta G2 minus delta G1. What is that? This is basically graphite to diamond. The change is basically graphite to diamond. So in that case, it will be the graphite to diamonds free energy change at the condition given and under given, and is at the initial the standard condition. So therefore we can write that delta G2 minus delta G1. We can write it is given as, because delta G2 minus delta G1 how much? That is basically, we know that is basically your that is basically given by the condition is basically 2.9 into 10 cube is given as joule per mole. That is basically delta G2 minus delta G1. So obviously we can write 2.9 into 10, or we can write side change. We get P2 minus 1, that is equal to 2.9 into 10 to the power 3. That divided by, we can get 2 into 10 to the minus 6. 2 into 10 to the minus 6 is in the Pascal. So therefore we can get P2 equal to basically is 1.45 into 10 to the power 4 bar. That means according to the question, this is approximately question number 21. This is we are solving. So this is basically they are given 14051. So it is almost equal to 14051 bar. So therefore the answer choice will be your A21. Answer is basically A21. Answer is A. So this is basically delta, and this is basically the VG equal to equilibrium assisted expressions. The application over here. Wonderful question. This can be applicable to anything I said just now. Thank you very much.